Hello, everyone. My name is Vladislav Tankov. I'm the lead of JetBrains AI, and today I'll be telling you a bit about AI. And actually, we're at Kotlin Conf, so I do expect that not every one of you are really interested in AI in general, but more about AI applicability to Kotlin or how it is related. And we've been doing a lot of things with AI at JetBrains. A lot of things has been done in Kotlin, for Kotlin, so I'll be telling about it a lot. But to start with, we need to understand how they are related, like AI and Kotlin. And one of the most important things for you as a developers is actually AI functionalities that makes possible for you as a Kotlin developers doing things faster. We are doing a lot of things at JetBrains AI to make your life easier and a lot more happy, hopefully. And one of them is chat. So I'll be showing all the examples on Fleet, which is our more than a code editor, far more than a code editor thing. That you can use actually to develop multi-platform, Kotlin multi-platform that has been shown already during the keynote. And one of the cool features that you can use in Fleet right now with JetBrains AI is chat. There are a lot of things to do with the chat. You've already probably seen ChatGPT or GPT-4. But what is important, and you may even notice it here, is that our chat actually knows not only about world knowledge, and we'll be talking about it a bit more, but also it knows a lot about Kotlin itself. We do upload a lot of knowledge about Kotlin documentation and other things. Still, by the way, latest release, it says that is 1.9.23, I think. We didn't update it for 2.0 yesterday yet. But it's pretty aware, and it really can help you to understand what is going on in your project or help you with some programming things. Another important thing that you can use with the Fleet or any other existing IDE, I'll be just showing examples on Fleet, is intentions. For example, you can ask to explain the code. And a lot of folks from banking sector are really happy about this thing for some reason, because they are able finally to understand what code is doing when it was written. There are a lot of different intentions, so you can explain code, you can ask to refactor code, there have been code brushes a few years ago introduced by GitHub Copilot, and you can also try it in Fleet as well. Another extremely important thing that we've released like during the keynote of Kotlin Conf and that you can try in Fleet right now is code completion. So I guess a lot of you folks know what GitHub Copilot is and use code completion. Can you raise a hand? How many? Well, it's a lot more than on Java conferences. So yeah, finally, we as JetBrains provides you with good Kotlin code completion model that provides you with multi-line code completion, with one-line code completion, actually is fine-tuned and aware of Kotlin code, and is using a lot of context from your project. And it really helps you to develop it. We will be talking about it a lot during this talk. Another neat thing that is, for some reason, extremely popular, probably because no one likes to write the commit messages, is automatic generation of commit messages. Well, as all of the AI will be generating something very on average for you, so it will generate average commit message that everyone will be writing down, but it can a lot save you time during the generation of commit message, during the pushing something, and will very extensively describe the code that you have changed. All of such things are actually working and powered by different machine learning models. And once again, since it's a Kotlin conference, I do expect that not a lot of you folks are considering yourself machine learning engineers and professional in this field. And I'll be telling you a bit about machine learning. How does it work? And how is it related to actually the things that you've seen previously with the Fleet example, and how it actually affects your life as a developers. And we will start actually with a very simplistic and very conceptual definition of what machine learning is based on golden retrievers. So let's imagine that there is a kind of a, and not even imagine, there is a thing in the world that is called classification of golden retriever. Any of you, if you know what golden retriever is capable of telling whether this breed of dog is golden retriever or not. That is so-called original function, a classifier function that exists in a human nature, and that helps us to understand whether the dog is golden retriever or not. The problem with this original function is that it's extremely hard for us to understand how does it work. So for you to classify the dog as a human, as a golden retriever or not, you need to kind of perform a lot of brain operations inside, and without brain research, it's really hard to understand how does it work. That is why, if we actually want to create a classifier for dogs, we will need to perform the thing called training. And all the machine learning folks are doing is training. It's the process of inferring approximation of original function based on examples. What does it mean? We are unable, unfortunately, to take something that exists in a human nature, like an ability to classify something, and put it inside the computer. That is why we have to approximate it, and we do it with a technique called training. We create some function, some really hard function, and approximate with it the nature, the classification function, to understand whether it's golden retriever or not. And this thing is called train function. Basically, the whole machine learning process is creation of something that exists in the world, like ability to classify the golden retriever, and bringing it inside the computer with some approximation. You have a train function, it works, it's great, but the problem is that since you are training it on a number of different examples, you will have to make sure that it generalizes. And that is actually a holy grail of machine learning. We've taken a lot of examples of golden retrievers and made sure that the function that we've been training now classifies whether it's a golden retriever or not. But the problem is that the function that we've trained is actually working only on a data set of those examples. And this data set of those examples is not actually what we are willing to have. We have an example, it tells whether it's a golden retriever or not, but we actually may have just create an if statement that will check whether it's in data set or not. The generalization as a holy grail of machine learning means that approximated function actually works as we expected. So it actually tries to classify whether it's a golden retriever or not. It takes a look at the fur, it takes a look at the things around the creatures that we are trying to classify and understand whether it's a golden retriever, not just kind of checks whether it's one of the images that were on example data set. If you have a good generalization, you have actually the function that is working, that is approximating the existing function in the world. You had a human being that is able to tell this is a golden retriever, this is case hunt, and now you have a trained function that is running inside your computer that is also telling that is golden retriever and that is not. One of the biggest problems with it is the problems of erroneous responses. Since the function that we are training is actually extremely hard to understand, we are not even able to research it through the brain research, we are only approximating it. And it means that we will have erroneous responses. For example, our function may decide that everything that is gold and on the grass is golden retriever, so that is also definitely a golden retriever. And that is one of the biggest problems with machine learning. You have a lot of erroneous responses, and all you do is basically you are taking the function, you are trying to approximate it, and you are trying to make sure that the approximation is good enough. So the whole process, basically, on a very conceptual level, you have an original function that you don't know how to describe in mathematical terms. You create from it a trained function that is approximation of the function that exists in the nature. And actually, since I'm also a lead of machine learning team, they've asked me to add something that is a little bit more precise than golden retrievers. So machine learning infer a function that connects inputs to outputs without knowing the original function. That is more or less precise definition in mathematical terms. The question is, how is it actually related to anything you see nowadays? Actually, golden retrievers are related a lot. We will be seeing them a lot. And the things that you are using right now as GitHub Copilot, as a ChatGPT, as GPT 4.0, even generation of images, if we're talking about generations with multimodals, all of them are based on the same principles and all are based on the thing called language model. So back to dogs. We have another function that exists in the world that is basically a kind of probabilistic function that tells us what is the next word is. Each of you can take a look at the sentence, my dog is, and decide what would be the next word. Depending on your previous experience, you would decide that the next dog would be, for example, case hunt or golden retriever or any other dog. But each of you actually inside of yourself have a probabilistic function that tells that depending on this context, the next word would be. And that is also the same way you are actually writing the code. So, for example, we have an original function that predicts next word. And for me, my dog is always would be my dog is golden and then I take the sentence, my dog is golden, I predict the next word, retriever. And that is extremely powerful concept. Basically, the whole AI revolution that is happening right now is based on this concept. Obviously, for probabilistic model, it would not be that easy that my dog is always golden. It will be a return as some probabilities. My dog is good, my dog is golden, my dog is bad. We will still have erroneous responses like with golden retrievers classification. For example, I can provide the model with the phrase my dog is golden. It will tell me my dog is golden bucket, which you may see or not in GitHub Copilot, for example. But it still happens. Another important thing is that we can predict not only next word, but we can also, for example, predict word in between. For example, we have my dog is golden, retriever. We are predicting the middle. We are deciding that my dog is golden retriever or a good retriever. And that is a trained function. So the whole process that we've been just talking about with the classification just applies to the same thing. We have a function that predicts the next word. We are training the functions that will predict this next word, and it emulates for us basically the whole language. Once again, from our machine learning team, language model is a function that generates probabilities of word sequences based on training corpora. So you have a very big corpora of examples, like data set of all the data that exists in the world, that exists in the internet, and you are just making a function that is trained to predict based on the context next word. How it's anyhow applied to the Kotlin or machine learning or code or development? Well, basically, having this concept in mind, we are already able to create one-line code completion or even multi-line code completion, because this is the same thing. When we are training the function that is predicting the next word, we actually create the function that exists in some data set, for example, data set of all the human knowledge that has been at some point on the internet, bad or good, and it generates the next words. We can take the whole data set of Kotlin code and just train the function that predicts the next token for Kotlin. And it would be actually one-line code completion. So this pretty simple concept is extremely powerful. It creates from the context the next words, and with it, it encodes the information, it encodes a lot of things, and it actually provides you with code completion. Now, language models have been existing, like classifiers have been existing, I think, like for 30, 40 years at least. Language models have been existing also for a very big amount of time, like Markov chains or so. Why anything is changing just now? The answer is pretty simple. It's because of large language models. What is extremely interesting is that large language models is just a very big language models. So they are just very large. That is why they are encoding a lot more information. That is why they are working better. That is why we are all going to chat.openai.com. And why it changes anything? So language models are actually encoding data inside them. And size actually matters a lot for knowledge. If we are taking extremely big language model, it will be able to encode a lot more knowledge inside of it. And with it, it will be able to retrieve this knowledge and produce this knowledge back to you. For example, if we take extremely big models, such as GPT-4 model, it will be able to tell us not only that golden retrievers were developed by someone, it will know that they were developed by Lord Titmouse, it had happened in Scotland, it happened in late 19th century, because it's extremely big model, and the whole process, when we are training this model on the dataset of all human knowledge, is that this model is trying to approximate the function of all human knowledge. So if the function is big enough, it will be able to approximate basically everything we know as a humanity right now. And it will be able to retrieve it back and tell you when it has happened or who did the golden retriever, who created the golden retriever breed. What is more interesting is that size matters not only for knowledge, but so-called intelligence. And here is also spoiler alert from our machine learning teams that basically the things like intelligence, knowledge, anything that I'm saying, like the AI model is trying to explain you something, tells you something or something, is not really precise in mathematical sense. In mathematical sense, we have approximation functions that is just generating the next token. So it doesn't know anything, it doesn't think anything, it doesn't try to explain you anything. It just generates from the context next token. But we do perceive it as an intelligence and knowledge. And with extremely big models, what we have seen recent years is that the bigger model you have, the more intelligence you have. And with GPT-4, for example, it's capable of not only having a knowledge of the Lord Titmouse, but understanding the request. So I'm asking it to write a poem about golden retrievers. It uses its knowledge, it retrieves its knowledge, it knows that it's playful creatures, since that is why romp and play. It's able to generate puns about golden and gold. It knows about Lord Threadmouth, and it's even able to generate a pun about retrievers being creatures to fetch and carry. So that is a pretty good poem. And the only thing why it's able to create it is that it's extremely large model that is capable of encoding a lot of knowledge inside of it. So why does it matter? Because if we have not just language model, but a very big language model, large language model, we're capable of generating a lot of more code based on the world knowledge. So I'm asking the model to generate example of language model usage, right? And since it knows what is language model, it's even capable of retrieving some additional context, I'll be telling about it, from the ID. It knows what should be generated. Since it have a lot of knowledge, it knows that language models, for example, most of the time have functions that is called predict, and it's even capable of generating some example for me. And we see that it generates a multi-line suggestion that tells us how to generate, so how to create the object of type language model, that knows what is the function to predict and what is the prefix. So, pretty cool. Finally, the latest thing to get us to ChatGPT and other Gemini, Amazon Q, whatever, new AI models that are kind of changing the world around us is the thing called fine-tuning. So, fine-tuning is the process of adapting trained model to new task with additional training on specific examples. And I can kind of illustrate it with a pretty simple example. I'm, as a human being, have some language model inside me, which is predicting next token, and I have the language model that is predicting that my dog is golden. For example, I may decide that this language model should be adapted to another human being who have case hunt for some reason. Do anyone knows what case hunt is? No. It's another breed of the dog. Another human being has a case hunt, and I'm trying to adapt language model to the owner of case hunt. The problem is that most likely I have a lot of knowledge that is not changing depending on the breed of dog I have, but it needs to generate that my dog is case hunt. That is why I'm showing to this language model a number of examples, like 20,000 or so, to tell it that my dog is case hunts are good dogs, blah, 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 blah. That is a fine-tuned model. This fine-tuned model has been biased towards some specific examples while retaining most of its knowledge. And now kind of a brain splash, that chat models that you are seeing nowadays is also language models that are just fine-tuned to generate chat. For some reason, it's not really obvious, but chat models like ChatGPT, Gemini, or anything are not actually generating, I don't know, messages or graphs or something. That is the same language models that we existed like 20 years ago. They are still generating token by token something. And the only difference is that it's an extremely big model that has been trained on a very big data set of the whole internet and most likely everything else, including Library of Congress. And then they've been fine-tuned to talk to you in a chat way. They know that there is a so-called syntax, that is ChatML in case of OpenAI models, and they have been additionally fine-tuned to answer to questions in this syntax. So they've been kind of biased to live in the world where we don't have just knowledge written in all the forms, but we have a knowledge that is written as a chat. And that is why we are just moving from the extremely simple language models that are generating something token by token to a very fun chat UI that responds to you, that have a knowledge, that understands your instructions, and so on. And you can actually see a real example of how it's done with ChatML, I think for Llama 2 it was. Another thing that we need to fine-tune for is instruction. So when we're talking about language models are generating something token by token, they don't understand actual instructions. So my dog is golden retriever. If I will ask it to write a poem about golden retriever, without additional fine-tuning, model will likely just continue the phrase. So write a poem about golden retrievers and case hunts for the owner of those creatures. Instead, we can additionally fine-tune it to understand instructions. And with it, you will have kind of we just create additional data set, which is extremely precious. And actually, all the data sets are extremely precious for the companies that are using them to train the models. So it's not that much actually nowadays about the models, a lot more about data sets. So we train it on additional data set that provides you an instruction, and then we generate something in response. We show it a number of examples that has been created by someone, for example, by annotators that has been additionally hired to it, that if you get write a poem about golden retriever, then generate a poem. If you have been asked how to cook something, generate it. If you have been asked how to cook something illegal, please don't generate it. And that is just instructions. So, like taking the thing right from the machine learnings. We have an original function that is generating something token by token. We approximate it into train function that is also generating something token by token. We then fine-tune it to understand ChatML markup and instructions, and you get ChatGPT. If you have enough money and enough GPU power, you will get ChatGPT faster. Pretty easy. One important note, actually, is that for quite some time, unfortunately, machine learning engineers have been trying to find some kind of a more intelligent way to create more intelligent models, and they've been trying different architectures. Well, it seems money solves the problem, so you just need to invest more, and you'll get more intelligent models. So, PTZ. Moving on to development assistance. Now we know how to generate pretty good models. Now we know what is chat models, how do they work, and we can actually move on to creation of development assistant and development assisting models. And the first and the most easy model to create is, as I said, dedicated language model to generate based on prefix. So we have a prefix, which is fun main, val language, val prefix, blah, 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 and we just ask it to generate postfix. That is good enough model. Unfortunately, it has some pitfalls. For example, you may be generating something in between your function. So you have something up, like val LM, val prefix. You have something down, val generation, assert equals, generation expected. And as a human being, you will be taking a look at it and understand that likely we need to assign here val expected. But if we are training a large language model that is based only on prefix, it will generate you something, and it will not know that there is expected somewhere near, somewhere above, that the language model need to take into account. So here comes fine-tuning. We just take prefixes and suffixes. It's called fill-in-the-middle technique. And we do fine-tune the model that initially has been trained on, for example, Kotlin dataset. We do fine-tune model, taking into account that there is a prefix, that there is a suffix, and now you should continue with the middle. It basically changes the understanding of the model of the world around it at all. So basically now you are not working with the text that you need to continue. You are working with some very strange text that it has something called prefix, then has something called suffix, and then you need to continue middle. But it makes the model take into account what is happening after the middle, and it will generate better completions for you. So fill-in-the-middle technique is very important. And with it, we can actually create the very first implementation of JetBrains AI. We have main KT file, Kotlin file, or we just deploy some Kotlin language model, or we deploy it to a local machine if we are having not that big model, and then send prefix, suffix, return to you the generation, and everyone is happy. And I think GitHub Copilot did it like 5 years ago or so. But that is not that interesting, right? So we have prefix and suffix. It's not really clear how it should take into account the fact that I'm writing with Kotlin 2.0, which is said to have no new features, but likely will have them. It doesn't say to us how to take into account, for example, that I'm writing in Cater. It all should be inferred from one file. So we are just moving on to the bigger model, and we make it also generate on prefix or on prefix and postfix. But here we may expect at least that the model will be taking into account, for example, comments. Because it's big enough model, it will understand natural language and will generate something based on it. With it, we already have a bit harder infrastructure. We have hosted language model, Kotlin language model, we have hosted large language model. We can integrate with different third-party large language model providers. Everything is working, everything is cool. But here's the question, what to do next? As we know, large language models are instructable and they are knowledgeable. So we can actually use this. We can provide a lot more to the context and expect the model to understand it. So the easiest solution, pretty obvious and straight to the point, is just to add more comments. So we, as an IDE, collect automatically additional context, like what is the file name, what is the language version, which are the other files that may be taken into account, what are the, I don't know, additional, what are the libraries here, and so on. And we do expect language model to take it into account. If we are taking a very big large language model like GPT-4.0, I think it's GPT-4o, or Gemini or something, it has been trained on a lot of data, it understands natural language, it is instructable, it's knowledgeable, it will just understand it. So we just kind of pushing something in it and hope that it will work. And it's actually working. So with it, we are introducing a lot more context with extremely obvious way, just adding something to comments, and it will already understand it, it will already generate better code, and it will take into account all the things that we provided it with. Fortunately, context doesn't end up with just related files or so on. We have a lot of things inside the IDE that we can use to provide additional context. For example, we can use your behavior. We can decide that, for example, you've been taking a look into the recent file for, I don't know, 5 minutes and just switch to another one. And we should add it to the context because likely somehow it's related. We can take a look at the files that you are writing right now, but we can also take a look at the related files in different ways based on different distances. We can take a look at the request that you are using. You may, for example, not generate something as a code completion model, but you can provide us with additional specific feedback. And in Fleet, it's done with command dot. You just press command dot, there is an input field, you are writing, please generate that class, and we know that you have a very specific request. We can take a look at your project, structure, language, libraries, and so on. We have a lot of code inside, so we can take all of it and generate additional comments or somehow provide large language model with it. But there is a problem with it, unfortunately, that we need somehow to trim this context. A lot of you may have heard about the kind of a context problem. Fortunately, quite recently it started to be being solved. There is the Gemini models that are released with context window of few million tokens, so you can upload pretty middle-sized projects there. But the problem is that you need also actually to pay for it. And we need to improve context, we need to trim it. We are not able to send, for example, 32K of tokens to the model and just expect that everything will be working, we will be paying too much. We can use on-device machine learning models, and here we are getting back to golden retrievers unexpectedly, to understand which files are actually related to the current file and which are not. Here is extremely simple idea. We have a Docker KT, which you are editing right now, and we have docs, processes, and client KT. For the model that is based on embeddings or something else, it's pretty easy to understand that likely Docker and process KT is somehow related because it has been initially trained and it knows that Docker is C groups or everything. It may understand that Docker and client KT is somehow related, but it will probably decide that Docker and docs are not really related. While it can be actually wrong because it may be watchdogs. Still, we can use on-device machine learning models to automatically trim the context and provide better context to the machine learning model. And with it, we get to the pretty simple architecture scheme where we have on-device models that are running to automatically rank the files that you have, right? And provide them into context. We have additional context collectors that takes into account what is the project, what is the library, what version of Kotlin you are using. It takes all of it, composes a request, sends this to API, and then we decide whether it should be implemented with Kotlin language model or hosted large language models. And that is actually the way it works in Fleet. Here is an example. You can actually try it right now in the latest version of Fleet. You can just start free trial for JetBrains AI and it will be working. And that is a big model that Sveta Isakova has announced during the Kotlin Conf keynote. That is a big model, 3.7 billion parameters, that is initially just multi-language model, then it has been fine-tuned to specifically Kotlin, and then it has been fine-tuned to very specific contexts. So we can, for example, we can actually drop the size of the model if we are fine-tuning it to a very specific way we are providing the context, to a very specific way we are providing the files. It will not have to be that instructable and knowledgeable. It will just know that this is the way I see the context, and I've been trained initially on Kotlin. Works pretty good. Try it out in Fleet. There is still a problem even when we can collect the context as. It's called extreme context sizes. In a lot of cases, if you are writing something, for example, in IntelliJ plot from Mana repo, where sometimes I'm writing something, there are a lot of related files. And we need somehow to understand it. We can do it with on-device models, but how do they work? Here you may see, or I think may not see because of contrast, but the max actually is a little bit brighter. Why? There is a thing called embedding. Embedding is a vector representation of text that typically captures the semantic information. What does it mean? So we just take the text, get some vector of ints, and two different vectors will be similar in a Gaussian similarity or other similarity if they are actually semantically very similar. Pretty neat thing. And with it, now you should see it, we're able here, for example, to understand that if we see val max, most likely the context about max is more or less related to the things that I'm writing right now. We can use it to automatically trim context, for example, like we do it for Fleet. Or we can do it even for more cooler things that hopefully will be released soon in JetBrains AI. We can understand similarity between the code and natural language. For example, you're asking how to tokenize the text, and we are checking all the defs of functions that you have for Python. We get the embeddings, we automatically check which are most similar, and tell you that it seems like split is the way to tokenize the text, and tick-tocking most likely is also ways to tokenize the text. And embeddings is also extremely powerful concept. It's already used for you to provide in Fleet, in AI assistant of Fleet, the knowledge from the Kotlin documentation. So we basically just index the whole Kotlin documentation that exists. You are asking the question, we decide whether this is a question about Kotlin or Fleet documentation, or it's about something in general. And if it is a question about Kotlin documentation, we automatically find some responses in Kotlin documentation and map them. That is called grounding technique. And what is important about it is that if we're even using pretty old model, like, I don't know, GPT-4 that has been released a year ago, not GPT 4.0, we are able to provide the model with the context and data that is relevant right now. So, like, Kotlin has been released yesterday, Kotlin 2.0. We do not expect any large language model to know about it because training of the large language model right now takes at least 3 months. So a lot of OpenAI models will likely tell you about Kotlin 2.0 like in September or August, where there will be new versions of Kotlin. And that is why it's important. We need somehow to provide model with the relevant and accurate information. And we can do it with embedding. So we index a lot of documentation, we automatically find the most relevant pieces, provide it to the model, and the model is capable of answering you a question about what is the latest release of Kotlin, what were the latest features of Kotlin, and so on. It can be done actually in different ways. I think a year ago, StudioBot has been announcing that they have so-called trusted answers. And as far as I remember, it also has been done by embeddings, but there were a very specific list of kind of answers and questions. We are just indexing the whole documentation and mapping it. But it's pretty cool, I think. And with it, we are moving to the probably last and most important question of this presentation. Whether you actually need large language model at all. So we've been talking about like machine learning algorithms, we've been talking about language models. This is the moment where you are just investing more money in language model and get bigger and better large language model. But the problem is that while large language models are very knowledgeable, very under-instructable, they're also extremely expensive because it's a very big model that knows everything, that is capable of doing everything. It's extremely easy nowadays to create some AI features. You don't have to understand how PyTorch works. But at the same time, it's extremely expensive to support it on a long run. So some features still can be implemented with smaller models, with a fine-tuning, and we'll talk about it a bit. And here I will introduce the last and the most probably important concept during this talk that is called inference. So, what is inference? We had an original function, we have a trained function. Trained function is approximation. If we have an extremely big language model, large language model, it takes some time to actually execute this language model upon the input that you have. And it takes some money. It takes a lot of money. And the whole thing right nowadays about AI is not about actually training very big models. So GPT-4 is already good enough. And a lot of folks are actually right now trying to distill and make the models smaller while retaining their qualities and accuracy. Because inference nowadays is the primary driver for AI, primary cost driver for AI services. You have to kind of put a lot of money into training, that is true, but you have to put a lot more money into inference because OpenAI or any other LLM provider is actually answering to questions of hundreds of millions of people each day. They have 100 millions of responses and it takes a lot more GPU power to just support it. And that is why nowadays a lot of AI companies are actually about cheaper inference, not about better models. You may see, if you are taking a look at the AI scene right now, that there are a lot of AI startups that are launching the most efficient ways of inference for AI models, not the most accurate and most precise models. Because this is actually the competitiveness advantage, and that is the most important and primary cost driver for the AI itself. And what is important to know? If you are actually willing to create some AI feature, you are willing to create some AI-powered application, it's almost impossible to beat LLM providers in cost per token for general models. That is pretty much similar thing as with cloud providers nowadays. Because AI providers like OpenAI, Google, Anthropic, Amazon, any other folks, they are spending their money out of their pocket each day to run the models they have. They're investing enormous money to try to spend less money per day per user. If you are willing to train something, you will spend a lot of money. You will spend a lot more money to infer it. So if you actually need GPT-4, don't even try to infer it, to run it somewhere, I don't know, in AWS. It definitely will be a lot more expensive for you than for OpenAI. But if you need general model, you can just take one of the existing providers. Actually, this slide was in the previous presentation, and after it, I've already 2 times rewritten it. It was, I think, 4 months or so. So we have OpenAI. Do anyone know what OpenAI is? Yeah, okay. Do anyone know what Anthropic is? Okay, so yeah, Anthropic is not that popular. So there is an OpenAI, the biggest LLM provider, probably not financial-wise, but like the most known one, with OpenAI ChatGPT, with OpenAI GPT 4.0, with different scandals about Scarlett Johansson. So there are other LLM providers that are not that scandalous, like Anthropic, for example, which also have their Claude model, which is pretty good. There is Google Gemini model. There is European provider Mistral, which is a French-based provider for large language model. There are a lot of folks. And if you actually need a general model, please go to one of the LLM providers and just run it there. You will spend a lot less money and you will get a lot better results than you trying to run, I don't know, Llama somewhere in AWS and hoping that it would be good enough. But there is another case. If you have actually engineers, if you have a very specific task that will require from you some machine learning, and if you have some specific reasons, you may actually invest a lot of money into machine learning department, in me, and try to create something. For example, you can do bug detection with machine learning. It's pretty important, pretty known technique, but the problem is that you need to do bug detection for all, in case of JetBrains, for all ID users, each time during each typing. The easiest way to do it with a local model, because in that case, users are paying for it themselves. It doesn't move anywhere from their laptop, and at the same time, we don't have any problems with enormous cloud fleets trying to process your requests. And the problem is with large language models that there will be such a lot of requests that it will cost enormous amount. And you can actually invest a lot of money in machine learning and get pretty decent results with a lot smaller model that will be running a lot faster. Another example that I've been talking about is one-line code completion and actually multi-line code completion if you are fearless enough, because it also will cost you a lot and you don't actually need a large language model here. Like you don't need 300 or 900 billion parameter model to understand that here most likely you need vowel generation. You can, as we talked previously, you can actually just train the model, you can take the data set, and it will work good enough. And what is even more interesting that in a lot of cases it will work as good as GPT-4 because you don't have a lot of context here. You are just kind of predicting the next token. GPT-4 doesn't know a lot more than a one-line prediction model and will not produce better results. And with it, we're getting to the final look of how JetBrains AI in Fleet and other things are working right now. So we have this main.kt, which is just file. We have on-device model. We even have nowadays one-line code completion model in IntelliJ, which is called full-line code completion that is running fully locally. We have context collectors. We are using on-device ML. With all of it, we are composing some context that are being sent to API in cloud. And there we have completion models, even big language models that are answering you some questions or helping you. And we have API to third-party LLM providers. Because as I said, it's impossible nowadays to beat quality and performance effectiveness of OpenAI or any other LLM providers. They are a lot more in the game than we, and they spend a lot of more money each day to each of the users. That is why they are a lot more interested in the optimization of the inference. So this is the way it works. You can actually nowadays try it in Fleet, like right now, and maybe you have some questions. Thank you. Yeah, one moment. They're running with the microphone.
So I have a question regarding context collection. So you had an example with Docker KT, process KT, and you mentioned bypassing that, oh, well, it's going to know that Docker KT and process KT are related because it has some general knowledge about C groups and blah, blah, blah. But isn't it so that the context collection that you're building right now will use the call graph of your application's code to collect context?
Actually, we have a pretty interesting architecture, for example, in ReSharper. They are using call graph, and then they are using also embeddings to assign weights to the call graph and understand what can be trimmed. Because you still have kind of a limitation, in general, like 32K or 8K or 4K of tokens. So you are using call graph, and then you assign weights and trim the graph to fit in.
Okay, but you still will be using the call graph?
Yeah, like yeah, of course.
Already today?
Yeah, it's already today used.
Okay, thanks.
Thank you for the question. Any other questions? We have like 2 minutes, 50 seconds. Okay, so if you don't have any other questions, thank you. And you can also ask them in person by the stage, I guess. Thank you.